So in the last session we were talking about the cross product. We saw the definition and some of the fundamental properties of cross product as a new operation for two vectors. So let's start with a quick recap of that. So we saw that cross product of two vectors is a vector itself of magnitude AB sine theta and direction given by the unit vector n cap, where we had learned that the unit vector n cap is the vector perpendicular to the plane of A and B and given by the right hand palm rule. So you had seen that in this relation magnitude of A cross B is AB sine theta, okay, and the direction of the vector A cross B is along the unit vector n cap, which is perpendicular to the plane of A and B by the right hand palm rule. Okay, so this was something important that we discussed towards the end of the lecture. The right hand palm rule, which tells us whether the direction is coming out of the plane or going into the plane. So let's start with a couple of examples based on this. Okay. So in this, we have to find the magnitude of A cross B, okay, and express the direction of A cross B as either into the plane or coming out of the plane in each of these. So the first one is like this, that to start working on this, I'm putting up the rest of the questions. Okay, so just use the principles we have discussed right above over here. Okay, magnitude of A cross B is given by this formula, and the n cap's direction is determined by the right hand thumb rule, which we had discussed last time. So to work out each of these four parts of this question, just try this out, people. Okay. Yeah, so Hitanshu, if you just go through my lecture notes, it provides you with what you are asking for, the formula sheet and the flow of all the operations that you need one after the other. You just systematically go through my PDF notes which I'm sending. They have all these things. So in each of those notes, you will see that there is the formula explained, then the particular special properties of the formula application, and then some examples of the application. So just use those lecture notes for that purpose of your own. Okay. Okay. Now let's come to each of these questions one by one. So anybody's got the first one? Yeah, I have shared the recordings. Sneha, all the recordings are shared on the WhatsApp group. Okay, you go through them. Up till last lecture, all of them have been shared so far. Okay, so magnitude of A cross B, use the formula AB sine theta. So here it is 20 into 30 into sine of 150 degrees. So there that is 600 into half. Because you know that sine 150 is the same thing as sine 30, the same thing as half. Okay. So this should become 300, should be mod of A cross B. That's the first thing. Okay. Now about the direction. Now for the direction you can see, make use of right hand thumb rule, thumb or palm, whatever. For A cross B operation, place your right hand palm, okay, with thumb towards A and fingers towards B. If you do this over here, you will see your hand like this. So your thumb is pointing towards the direction of A, and your fingers are pointing like this. Okay. So your palm will be facing towards you. So notice that palm faces outwards. So what does that mean? That implies that n cap is coming out of the plane. Hence, the direction of A cross B is out of the plane of A and B. Okay. So this is something you have to practice a little bit and get used to. The right hand palm rule. Yeah, so hope this question is clear first of all. Then let's go back to the questions. Okay, now work out each of these. Okay, so I'll just tell you the answers of these now. This should also be coming out. This should also be coming out. And this one, the answer should be 0. Okay, so have you understood the rest of these questions? So let's just draw some diagrams and understand these. So if we go with this one, what you'll understand here is that geometrically the vector E is going towards east. So it's like this, let's say, and the vector B is like this. It is 60 degrees east of, sorry, E is going towards north, my mistake. So the vector E is like this, going towards north 50 units. Now this is your south and this is your east direction. So the vector B that is 60 degrees east of south, that will be somewhere here. It will be like this. 60 degrees east of south. वैसा होगा. And its magnitude is also 60 units. Okay. So then what is the angle between A and B? You can see the angle between A and B is 120. Okay. So magnitude of A cross B is becoming this much. 50 into 60 into root 3 by 2. That's how it is 150 root 3. Oh, sorry, 1500 root 3. My mistake. Not 150, but make a correction over there. The magnitude is 1500 root 3. And about the direction, now once again, this time when you apply the right hand thumb rule, you have to place your hand such that your thumb is like this, your right hand thumb is like this, and your fingers, they are pointing. You have to stretch your hand a little bit, so your fingers are pointing like this. So when you place your hand like this, you will see that you're looking at your knuckles. Your palm is actually facing in. Palm is inwards. Okay. So that means what is the direction? A cross B is into the plane, not coming out. Okay. So magnitude of A cross B is 1500 root 3 in this case. Okay. And direction is into the plane. Going straight in. Okay, so this was the second part. Let's work out the third and fourth part. So this was incorrect. It was into the plane, not coming out. And the magnitude was 1500 root 3, not 150 root 3. Now let's work out this part. So here one very simple thing we can do is we can just draw the given two vectors in the xy plane. So we just geometrically construct these vectors. Yeah, second is going in only. It is not coming out. Okay, I have explained. You can see the diagram with Anshu once again and figure it out. Okay, it's going into the plane, not coming out. Just finish this, then we move on to the third one. Okay, let's come to this one. Yeah, so in this, if we construct the vectors A and B, they will look something like this. The vector E, as you can see, it has a magnitude of 5 and it is at 53 degrees with respect to x-axis. Because you can see tan theta is 4 by 3 like this. So from the component algebra, which you have seen many times before, you can understand that the vector E is somewhere like this. Its angle with the x-axis is 53 degrees. Its own magnitude is 5 units. It's in the first quadrant like this. Okay. Whereas when you talk about the vector B, you can see the magnitude of B is 15 and it's in second quadrant. This minus 12 and this 9. Its angle is 143 degrees with respect to x-axis. You can easily see this because B is lying such that, see, this component is minus 12 and this component is 9. So this is where the vector B is. So you can see easily that this angle is 37. So this is 9 by 12. So that means the angle with the x-axis, that is how much? It is 180 minus 37, or it is 143 degrees. Okay. So you can see that the vector B in comparison is like this. So magnitude is 15 and this angle must be 90 because this total angle was 143 degrees, or this angle is 37. Okay. So this time you can see that magnitude of A cross B is 5 into 15 into sine 90. So that is 75. Okay. And the direction, now for the direction, once again you have to apply the right hand thumb rule. So this time your thumb is pointing this way and your fingers are once again pointing this way. Okay. So your palm is facing outwards. When you look into your hand, you can see your palm. It's not facing the other way. So, okay. So direction is coming out. You can do one more thing. You can understand that E dot B is 0. Just check from above. E is 3 I cap plus 4 j cap. B is minus 12 I cap plus 9 j cap. So that also confirms that theta is equal to 90 degrees. Okay, so hope this one is clear, people. Now moving to the last one, you will notice that the vectors I have given you are opposite to each other. The last one, if you just read the question once more, you will see the vectors are at 180 degrees to each other. They are opposite to each other. So obviously their cross product is 0. In this one, just see the vector B is minus of vector A in fact. So the angle between them is 180 degrees. So obviously A cross B is a null vector. Okay. So this is clear now. Say how you understood the fourth one. Okay, good. So with this you can calculate the cross product between vectors when you know the angle between two vectors and you know their magnitudes. Now next up we will see how to calculate the cross product for three-dimensional vectors. So component form. So cross product in component form. So for that first we will understand the unit vector cross product notation, that I cross I will be 0 because they are parallel to each other. J cross J is also 0. K cross K is also 0, but I cap cross J cap is by definition K cap. Now how we can understand this? Just visualize the three-dimensional component system or the coordinate system. So we've seen earlier that if your x and y axis are like this, so your xy plane is like the wall in front of you, then your xz plane is like the floor, three-dimensionally speaking. So this is your xyz system. So naturally you can see now that in this system, your unit vectors I cap and j cap are like this. They are vectors of magnitude unity each, and the angle between them is how much? 90. So if this is I cap and this is j cap, you can see that I cap cross j cap will have a magnitude of 1 into 1 into sine 90, okay, and some kind of direction n cap. But now n cap will be by right hand thumb rule or palm rule. If you draw your x axis like this and your y axis like this, then n cap is coming out. So if it is coming out, it means that it is nothing but k cap, because outward is the positive z axis. So this is the direction of n cap now. So this is your n cap equal to k cap. So it becomes nothing but k cap. So that's how we get this principle, that I cross j is equal to k. Now similarly, if you see j cross I, it will be minus k, because it's just the opposite operation. So the direction becomes opposite. Similarly, if you see j cross k, that will give you I cap. But if you see k cross j, that gives you minus I cap. Once again, you can figure that out from this diagram of the three-dimensional system that I made. And similarly, if you take k cross I, it gives you a unit vector along the positive y direction. So that's j cap. Whereas if you take I cross k, it gives you the opposite of that. So that is minus j cap. So each of these six pairs now of cross products that I've written, you can figure them out by using the right hand thumb rule. No, we have seen earlier that the cross product of any vector with itself is 0, because sine 0 is 0. So this is something we have seen before. So that's why I cap cross I cap is 0. So these six formulae over here, there's a very simple way to remember them. X, Y, Z, or I cap, J cap, and K cap, they follow a circularity. So if you go along this circular arrow x to y or y to z or back from z to x, you get positive sign. So I cross j is k, j cross k is I, and k cross I is j. But if you go opposite to this, you go in the opposite sense now like this, then you will get the minus sign. So y to x will give you z but with a minus sign. So j cross I is minus k. So this is a simple trick or a mnemonic to remember this principle. Obviously, the logic of it is the right hand palm rule, but a simple way to remember it, that which of them will have the minus sign and which of them will come without the minus sign. When you take cross product between two unit vectors, they should not be identical, of course. So which of them have the third unit vector with plus sign and which one with the negative sign? You just remember it by this simple tool. Okay, so make sure you are clear about this. The relationship between the cross product of two unit vectors which are not identical. Obviously, the cross product of a unit vector with itself is zero. And apart from this, you also keep in mind the following properties of cross product. One is that cross product is non-commutative. That means A cross B is not equal to B cross A. It is minus of B cross A, because magnitude of A cross B is equal to magnitude of B cross A, which will be AB sine theta. But their directions are opposite. So, for example, if this is your vector A and this is your vector B, you can see that A cross B, apply the right hand palm rule like we've been discussing so far, it is coming out of the plane. It's normal and coming out of the plane. Whereas B cross A, it is going into the plane. Again, apply the right hand palm rule and you will understand why that's the case. Okay. So they are opposite directions. So this property shows that it is a non-commutative operation. Yeah. So we're going to need these properties as we discuss cross product of vectors in component form, which is why we are writing them down here. All right. The next important property is the distributive property, which follows like this: that A cross of B plus C is equal to A cross B plus A cross of C. So this is called the distributive property. So these few properties of vectors that we have written down, cross product of vectors that we have written down, they are going to be used now in our understanding of the component notation of cross product. Okay, now let's see how we can make use of these to come up with component of cross product formula and component algebra. Just a moment, I'll reshare the file. Yeah. Okay. Now, for example, suppose I have this vector I cap plus 2j cap, and I have a vector b which is, let's say, just 3 I cap plus k cap. I want to calculate A cross B. Okay. And I want to calculate the magnitude of A cross B. So what I'll do is just make a substitution here in A and B with their individual component form. So it is this. Okay, so substitute the value of A as given. So I cap plus 2j cap, and substitute the value of k as given. Sorry, B as given, which is 3 I cap plus k cap. Okay. And now just apply this property over here, this distributive property, to expand this algebraically. So this becomes I cap cross 3 I cap, okay, plus I cap cross k cap, okay, plus 2 j cap cross 3 I cap, plus 2 j cap cross k cap. Okay. Now to solve this further, just recall what we had discussed about the unit vectors cross products. Okay. We had seen this XYZ circularity thing, and we had seen that cross product with itself for any unit vector is 0. So just apply that principle over here. So what will the first term become? It will become 0, because I cap cross I cap is a null vector. So this is 0. Okay. But what about I cross k? That will become minus j, because I cross k you're going against this. Okay, then what about j cross I? It is plus k, so this will become 6 times k. Okay. Because you can see from here that j cross k, sorry, j cross I missed it, should be minus k. So this one should be minus 6k, because j cross I is minus k. So 2j cross 3 I cap should become this. Okay. Now similarly, what about this one? J cross k is I, so this will become plus 2 I cap, because you can see from here that j cross k is I. So that's finally your vector. So A cross B is, according to this, is becoming 2 I cap minus j cap minus 6 k cap. Okay, and therefore its magnitude is nothing but the magnitude of this vector 2 I cap minus j cap minus 6 k cap. That is further, you can calculate like this. That becomes your answer. Okay, that's fine. Don't worry. But have you understood how these steps worked out? So to calculate the cross product, what we did here is we substituted A as this vector. We substituted B as this vector. And then algebraically, we worked out the steps first of all by using the distributive property. We expanded this thing. Okay. And on expansion of this, we use these principles for the cross products of unit vectors that we just discussed earlier. Okay, so just complete writing this down. Then we'll discuss a shortcut method of doing all this. Because as you can imagine that if that each of them had three components A and B, then this would be a very lengthy method because on expanding it we get 3 into 3 9 terms. So if we are talking about two vectors, each of which have three components, and we are calculating the cross product, then expanding it by distributive property will give us 9 terms. So it becomes very lengthy and complicated. So we'll discuss a shortcut method of doing the calculation also. Okay, so next up, we will see a shortcut method or a direct formula method for calculation of these cross products. So, cross products in component form using determinant method. So, I'll explain what is determinant method. So, first up in this, we will discuss two-dimensional components form. So, in this, we have to calculate, suppose vectors A and B are in the xy plane, and we want to calculate A cross B. So we'll see a method. Now this method involves something called determinant. So I'm explaining that. Determinant of a 2 by 2 matrix. Let's understand what this is. So a 2 by 2 matrix is nothing but a linear array of two rows and two columns. This kind of thing. It is called a 2 by 2 matrix. And the determinant of this 2 by 2 matrix is given by a simple relation, this. Okay, so basically it is this diagonal minus of this diagonal. Okay, so it is basically d1 minus d2. This is we are calculating. Okay, so this is a simple, mathematical formulation that we use, that we can arrange four numbers or four variables or whatever in into two rows and two columns. Okay, and when we do that, we call that system a two by two matrix. So now the determinant is a particular calculation done on that 2 by 2 matrix, which is given by this formula. Okay. You might have seen determinants before in the Kramer's rule and application of linear, uh, this thing, simultaneous linear equation solving. So it's the same thing if you've seen it there earlier. In case you haven't, it doesn't matter. Now, how we make use of determinant here, let's see. So when A and B are two-dimensional vectors, we make a 2 by 2 matrix. And the first row of the 2 by 2 matrix is nothing but A's components, and the second row is nothing but B's components, and that is multiplied by k cap, and then we calculate the determinant of this. So the determinant of this is going to be nothing but this diagonal minus of this diagonal. Okay, so it's going to be ax multiplied by by minus of ay multiplied by bx into k cap. So this becomes the A cross B vector. Okay. So let me explain with a numerical example, then you write this down. It will be less confusing. So for example, suppose I have the vector A, which is 3 I cap plus j cap. And I have the vector B, which is 2 I cap minus 2 j cap. And I want to calculate A cross B. So what I'll do here is to calculate, since A and B are two-dimensional, both in the xy plane, I will draw 2 by 2 matrix, and the first row will have A's components. So A's components are 3 and 1. Second row will have B's components, which are 2 and minus 2. And I'll put k cap on the side. So this will become 3 into minus 2 minus 1 into 2. The whole thing is the determinant. I mean, yeah, of the matrix. So this is minus 6 minus 2 k cap. So it is nothing but minus 8 k cap. So this is my A cross B. Okay. This is the value of the vector. Okay. So now just write this down, and after this just work out these examples. Yes, very good, Shrey, that's correct. Shrey, that's correct. Sumit, you have to give the unit vector also. Your magnitude is correct. Yes, it's correct, Om. So good, all of you getting the first one correctly. Okay, so let's check out the answers. So for this one, the answer should be 12 k cap. So you can see directly A cross B. Put A's components 12 and 16, B's components 3 and 5. So it is 12 into 5 minus 16 into 3 k cap. So it is 12 k cap. Okay, so that is your A cross B. Then this one, first calculate Q plus R. That is the easier thing to do. Rather than use distributive property, 2 I cap plus 4 j cap, we have to add with the vector minus I cap plus 4 j cap. So that is becoming I cap plus 8 j cap. Okay. Now you calculate your P cross Q plus R. So that you put P's components, which are I and sorry, 1 and 2 respectively. Okay. P's components here. And then Q plus R's components. Q plus R is this one here. So put this one's components here. So as you can see, this is becoming 6 k cap. That is the answer. Okay. So this whole quantity is becoming 6 k cap. So good, that is correct. Okay, so I think this should be simple enough. Hope all of you work this out. Okay, next up, let's understand the same thing in 3 dimensions. Now, 3 dimensional component form. Okay, using the determinant method. So we want to calculate A cross B here. So here we make use of the next type of determinant for a 3 by 3 matrix. Determinant of a 3 by 3 or 3 row and 3 column matrix. So a 3 by 3 matrix looks something like this. First row, second row, and third row. 3 rows and 3 columns. Now the determinant of this thing is a little bit complicated. So let's get into this now. Determinant of this particular matrix, how we'll calculate, let's work that out. So this is broken into steps. The first step is we make it a smaller problem by reducing the number of rows and columns. So what we do first up is we take A1 out. Okay. So once we take A1 out, we are left with take the first row and first column out. So we are left with B2, B3, C2, C3. Next, what you do is you take A2 out, but the middle term A2 always comes with a minus sign in between. Okay. So now take the first row and second column out. So remove this out. Okay. Because you're taking A2, so remove the middle column out. So left with the first and third columns. So that is nothing but B1, B3, C1, C3. Okay. And then finally do the same treatment with the third one, but the third one again comes with a positive sign. The first and third come with positive sign, the middle term comes with a minus sign. So now remove your third column. So left with first and second column. So this will be B1, B2, C1, C2. And then just solve this further according to the determinant rule. So A1 gets multiplied with this determinant. So that is B2, C3 minus B3, C2. Then minus of A2 gets multiplied with this determinant B1 C3 minus B3 C1. Okay, and then finally A3 gets multiplied with this. So this is the way of calculating this determinant. Just note this down. We'll practice a couple of determinants, then we will discuss about how to use this with cross products. Okay, so let's practice these steps out with an example determinant first, then we'll come back to the vector applications. So for example, we want to calculate determinant of this matrix. Let's say something like this. Okay, you want to calculate its determinant. So we'll just follow these steps here. Okay, so first step is the determinant equals. Now you have to take each of the things out. Okay, so I'm taking 2 out. So I'll take the first row and first column out. So 2 will get multiplied with the determinant of this second row and third column. So that is 5, 6, 5, 2. Okay. The next I will take this one out. And remember the middle term always comes with a minus sign. So remove the middle column. So the first and third column, 7 and 6, 3 and 2. Okay. And then again take the last one out. So last one again comes with a positive sign. So plus 3 into now this determinant. Okay. The first and second column. So that is 7, 5, 3, 5. Okay. So this becomes 2 multiplied with 10 minus 30. Okay. Minus 1 multiplied with 14 minus 18 plus 3 multiplied with 35 minus 15. So that is again minus 20 into 2, so that's minus 40. Minus 4 into minus 1, so that's plus 4. And 20 into 3, so that's 60. So that becomes how much? That becomes 24. So the determinant of that matrix has a value of 24. So this is an example of how to calculate the determinant of a 3 by 3 matrix. Now next we'll see how we make use of this in vector algebra for cross product. But first write this one down. Okay. Now when it comes to vectors, let's see how we will utilize this. So to calculate A cross B, what we will do is we'll make a three-dimensional or 3 by 3 matrix. Now the first row of that matrix will in fact be the unit vectors. So it will be I cap, j cap, and k cap. The second row will have the vector A's components, that is Ax, Ay, and Az. And the third row will have B's components, which is Bx, By, and Bz. And then we will solve it by just this method that we are seeing here. So next step, you will take the first row's first column out. So I cap comes outside. It is multiplied with this 2 by 2 matrix. Okay, so that's going to be Ay, Ez, By, Bz. Then you take the minus j cap outside. The middle term, remember, comes with a minus sign. So you're left with first and third column. So Ax, Az, Bx, Bz. And then k cap outside. So you remove the third column. So first and second columns are Ax, Ay, Bx, By. And then you just write out the determinants of each of these. So this becomes Ax, Bz, sorry, Ay, Bz. Mistake. So Ay, Bz minus az by into I cap. Okay. Then in the middle term there's a minus sign, ax bz minus az bx I cap. And then the last term again comes with a plus sign, ax by minus ay bx k cap. And this becomes your cross product finally. So instead of remembering a very lengthy formula, or instead of doing the operation with 9 terms and all that, okay, so we can't take that way. We are learning right now cross product of two vectors, a cross b like this. If there are, I mean, you will not have in physics right now, but if you have an equation like this, there will always be a bracket on two of them. Okay, so it will be this or it will be this. So you solve this bracket first. Okay, so solve this first and then take the cross product of this one with this. Or in this case, you solve this first and then take the cross product of this with this. Okay, so hope this is clear. Hope you understood now. At this level, we are only doing cross product of two vectors at a time. But if there are three or more, then there will always be some bracket in the operation. Without that bracket, it won't make sense. And the bracket will be solved first, then the cross product with the next time. Okay, so once you get used to this determinant thing, it's pretty easy. So let's just work out a quick example or two. So suppose we have this I cap is not there two times in the formula, but I cap तो एक ही बार. Oh sorry, this is j cap. My mistake. Is the middle term, right? It comes with j cap. Is this second term? So this should come with j cap. So if you written I cap here, please make a correction. This should be j cap. Okay. So basically this term, this whole term is this one now. Okay. Anyhow, so we'll see some examples, numerical examples, and this will become very easy. So this is there now. Now we want to calculate A cross B in vector notation and its magnitude. Okay. So it's very simple. We want to calculate A cross B. Just first of all make a 3 by 3 matrix and populate each of the rows and columns. So the first row is what the unit vectors I, J, and K. The second one will be what? A's component. So that is 2, 1 and minus 1. In the third row will be B's components, which are 1, minus 3 and 2. So this is done. Now just solve it like a normal determinant problem. So take I cap outside. So second and third row. So 1, minus 1, minus 3, 2. Okay. Then take minus j cap outside. Just remember that the j cap always comes with a minus sign. So first and third column. So that is 2, minus 1, 1, 2. Okay. And then take k cap common. So first and second column. So 2, 1, 1 minus 3. These come out. So now solve each of these determinants. So this is 2 minus 1 into 3. So that is 3. Okay. Then minus of 4 minus of minus 1. This will go with j cap. Don't forget the minus sign outside. Okay. Plus, this will be minus 6 minus 1 k cap. So what I'm getting finally is minus I cap. Okay. Then minus 5 j cap. Okay. And then minus 7 k cap. So this is the A cross B vector. So this is one of the things I needed to find out. Now next it's magnitude. That is just mod of this thing. That is square root of 1 square plus 5 square plus 7 square. So that is square root of 1 plus 25 plus 49. That's square root of 75, which we can further simplify and write as 5 root 3. So that is becoming our magnitude of A cross B. That's the second thing we did. Okay, so this is very simple once you practice it out a little bit, calculating the cross products using the determinant method. Okay, people. So hope this is clear. So with this, we finish the theory portion of vectors today, and we will discuss some questions from the module and your assignment 6 and 7 in the next lecture, and we will wind up vectors. The next chapter we'll be doing after this will be Newton's laws of motion. So if you want to go ahead, you can start reading Newton's laws of motion from H.C. Verma or Resnick Halliday, one of the reference books, or even from the module, because we'll be coming to that very shortly. Probably we'll take an introduction into the chapter in the next lecture itself if we finish the questions of vectors. Otherwise, next to next week. Okay. So that's it from my end for today, people. Wish you all the best.